The physics of AI is determined by the platform that you're running them on, right? And it's like, if you change the fundamental physics, then, you'll be able to run different kinds of models. And that's actually one of the reasons why these chips are actually they're built on an older process node than NVIDIA chips are. And they're built with cheaper memory, but they're still able to perform very high, and they're very cheap on top of that.
What's your overall goal and mission of this project?
Code base for this stuff is massive. So we have a 8, 6, 32 gigabyte memory. I used to, the thing is, talk about KJ, I used to watch KJ's channel when I was in high school.
With this video and with the videos that I'm about to be posting on this channel more frequently moving forward, I really wanted to showcase the really incredible young minds that are around me on a day-to-day basis. A lot of them never been on any sort of podcasts or have showcased any of their work to the masses, and so I'm giving them that opportunity, and also from my side trying to make them as comfortable as possible so they can share all of the really juicy insights. Today we're talking with Caleb, who is building an AI system from the ground up. He has a server just in another room that you'll see him walk through, see his thought process, and at the end of the video he'll also give advice as to how someone could even start a project like this. So I think this is really fascinating. I'll have more videos even with him specifically lined up, and just incredibly excited. Yeah, so we just went right downstairs.
All right.
That's where Howard lives.
Very loud.
So when did Howard come to be?
When did he turn on properly for the first time, or when did he
when were you theorizing?
Theorizing? I think I theorized about Howard. I remember, I was in New York at my friend. I was going for some meeting, and I was at my friend's place, and I was in bed. TensorRent had to release some stuff, and I was just thinking about it, and I was like, I could just build a server. I could just do it. So then I was like, cool, and because these are actually relatively very efficient, cost-efficient chips for the amount of compute power they give. So I was like, cool, I'm gonna set it up, and I was talking to some friends. I was like, we could get this going. We could buy some chips, and then by the next morning, actually, I got the funds. So I was like, cool, and we ordered everything. We ordered the chips mainly. So then I talked to this guy. He's actually a senior engineer at SpaceX. He works on the Starlink system, and I was asking him because he buys a lot of old servers. I was like, hey, how should I do this? He was like, you should just get old servers. So this server is it's like a Gigabyte G20. And it used to work with NVIDIA H100s. A100s. So normally you can see it has 1, 2, 3, 4 pods. Each of them would hold 2 chips. So I was like, cool, I'll just buy this. And it was actually pretty cheap. It was $1,000 for the entire thing with the CPU and everything. So it's pretty cheap. So when I got that, I got the chips. So what happened is there were a bunch of problems, with getting it set up. So actually, I can show you here, because this is the old motherboard here. So this is old power delivery board, PDB. This is the power delivery board, or a power delivery board. You can see all the ports. This distributes power, so these would be the ports for the 4 GPU ports. These are all the fan ports here, main power ports here. This is actually where it plugs into everything in the base. So there was a problem with a sensor here that was getting all the current reading. So there's a very high current reading for some reason, 80 amps, which is not good. So I talked to the manufacturer, and then I actually replaced this part, and it wasn't the issue. So then I had to get a new motherboard, which is currently inside, but I'll show you what it looks like. I did a new motherboard, and once I replaced the motherboard, then everything started working normally. But that took about a couple months. It was a month or two before everything kind of coalesced. But I was here. I remember I was going to San Francisco. I had to get on a flight, and I was really trying to get everything up and running before the flight, replacing everything, getting everything set up. And I was really disappointed. It was really crushing. I was really pissed. And I had been thinking about it the whole trip. I need to get this up and running. I need to get this back. And then by the time I got back, I took everything apart and I put it back together one more time. And then that started working. So that ended up going well.
So can we take a step back and 1, where does the name Howard come from?
Yes.
2, what's your overall goal and mission of this project?
So Howard comes from this book called The Medusa Chronicles, right? And it's basically about this guy. He's he was like the equivalent of like an Air Force pilot or like a Space Force pilot or something. And they were doing this like training run, and he got into this big accident, and they basically had to like save his life using these like, very like, military grade, experimental procedures that essentially like made him like part cyborg. And like it took like 10 years basically to get this guy back to health. And like his name was Howard. And the cool thing about Howard is that he basically he like lived for a very long time because he was like part robot, so they were able to replace his parts. And like modern medicine at the time was like 2100 something when he like had this accident, so it was pretty futuristic. It was so advanced that like he ended up living for a very long time. And he ended up observing like as AI became a major part of human society, he was kind of this middle ground between, and like no one else got this kind of treatment, because it was very experimental and military stuff. And by that time they figured out how to do it with like actual human parts. Then he just never got that. But he became this like kind of middleman between AI and humans, robotics and humans, and he kind of got to observe what happened. And it was just like a beacon of like middle ground between this kind of like merging of man and machine. So yeah, Howard is going to be, my big first like AI system. And like the point I think is to like, train some interesting models on it. So the initial goal was to start training some like LLM, like diffusion models to get them up and running, both training and inference. So there's going to be a couple steps between that. And I think there's a lot of cool steps, I think, for the project in general. So I think at a certain point, we're going to get like FPGAs and use them as a kind of like routing mechanism.
And for people...
Oh, FPGAs are like kind of like chips that are configurable. So like when you program chips, what you're really doing is just like, you're executing like a generic circuit and you're just like looping. So each instruction is like one loop of the thing. Whereas like an FPGA is like you're programming the actual like physical circuit. So you're almost like programming the actual chip itself. So they're very fast and they're basically like for very low latency scenarios, but they're very hard to program. So we're going to use those to kind of make this like a routing layer. And like we'll talk about this a bit later when we're talking about how the actual chip works. But using them to kind of expand the total amount of memory on the chip so you can train a lot bigger models with a lot less flops.
Sounds good.
Yeah.
Anything you want to show me on this side?
Yeah. So it's a very janky setup that I've got set up here. And it is because the two chips that are in the pod also have two fans that are adapted for working with them. So, and normally like they would be housed in a different, so it's called a 6 unit, or 4 unit container. This is a 2U. So it's very small. So I have them on the sides, but there's fans on the back. So I'll actually take it out and show you guys. That right. So this is the back side. So this is actually what a case looks like. I'm going to take it over to the side here. But yeah, so this is what the chips look like. These are Tensor N3100s. They're Wormholes, the server edition. So these are the two fans. These are the two actual cards. This thing right here is called an Ethernet bridge. It lets me basically... So there's actually two chips on here. One here and one here. So these let these two chips talk to each other with fast interconnect. It's like 100 gigabit per second Ethernet connection here, so it's pretty fast. These are some QSFP cables. They would go into here, and these actually have 400 gigabit per second connection. So I think when you're programming AI computers, most of the time you can't really fit all the data on one chip. So you're trying to distribute it across multiple chips. And you have to have very fast connections to communicate between them. Yeah, so the interesting thing that I did here was that, so each of these chips has its power supply, which plugs into here. This is actually what a baseboard would look like. So the chips would slot here and here. There's a little heatsink. And this is where the actual power supplies are. But to power these fans, you need something called a PCIe power cord. And these use something called, the baseboards are called EPS. They're just like what CPUs get programmed. They're very high voltage. Each one is like 300 volts, 300 watts for each card. So I basically use, and these are actually the old connectors for what you would plug into the old A100s, and they would have two of these. So I basically used one of these ports to power each of the fans. And so I've connected it so that they're both kind of linear like this, and then the power kind of flows. Now, if you see the board, you're like, hey, Caleb, why is there a big kind of missing thing here? And why is this chip here? Because before, what I wanted to do was have both of them on that side, which is why, and the fan casings are removed on this side as well. We can come over here. So normally what I'd wanted to do was kind of put one here, and then loop the cables through so I could get 8 chips all interconnected. But there's some problems because of this little thing here, that little bridge, it sticks out. So I basically had to reverse it over to that side because, as you can see, they're upside down here. And if you flip it over on the other side, then they're facing down. So I had to take a bolt cutter here. And I think I'll send you the picture of that while I was doing it to explain. But I had to take a bolt cutter and basically take off this fan and rip out this part so that I'm going to get a 2-meter cable and just pass it from there all the way around to here. So we'll get like full 8 chips connected, but that's going to take some time to get. So yeah, that's how that thing was. And I mean, I guess I can also talk about this. So we have a 8.6 so 32 gigabyte memory. So it's 512 gigabytes. Or no, it's like 200 something. I don't know. It's too early for math. No. So yeah, we have a lot of memory, DDR4 or 5, I think. And yeah, and there's like a nice NIC over there, Intel NIC. And the BMC. So this is how the system works. The CPU is mainly here, connects to this memory. The other interesting thing about server grade, what's it called? Servers in general, that I didn't know before, that I don't know if you might like, is there's actually a whole another processor right here called BMC. And the entire job of that processor is just like manage setting up and booting the entire server itself. So actually, little processor has its own like web portal. So I actually manage all these things from like the internet, and I have like a little website that lets me like monitor all the logs, monitor like any like the temperature, any sort of events that happen. That lets me monitor right there. And then obviously I have like TensorTorrent software that lets me interact with the actual chips themselves. But yeah, this is Howard.
I'm curious what the story is about you getting this in this building here.
Yeah, so I remember it was like I went to a Link event. And I think they were talking about AI, and you might have.
It might have been just out here.
Yeah, it was literally just out there. Yeah,
let's go out here for context.
Yeah, it was literally just out here, and it was the GOAT, John Werner, and Dave, and they were kind of giving a talk. And John does this thing at like events to like keep people engaged, where he'll like get a mic and he'll go like, "Hey, give me some like things you got from this thing," or like, "What do you think about this?" or "How do you think whatever we were talking about will impact what you were saying?" And so there's a bunch of like MBAs talking about how like AI was gonna like change how they saw the world and like these new models and whatever, and like no one was talking about the hardware. So I'm like, oh, I had to say something, and I was like, hey, like there's so many new chips coming out. The physics of AI is determined by the platform that you're running them on, right? And it's like if you change the fundamental physics, then you'll be able to run different kinds of models. And that's actually one of the reasons why these chips are actually like, they're built on an older process node than NVIDIA chips are, and they're built with cheaper memory, but they're still able to perform very high, and they're very cheap on top of that. So like I made a statement, and Dave was like, yo, we should talk after. And I was like, nice. So we talked, and he was like, yeah.
Dave is the general partner.
Yeah, general partner, Dave Blunden. And yeah, he's like, come up. And then I basically started coming more and more, and I was like, hey, I have this project, can I keep it here? And they were like, hell yeah, let's do it. Shout out Ken, shout out Leo for helping me set up, and Geach for getting all the network set up, helping me get all the power, figuring out power problems that we were getting with current.
I think one of the big focuses at Link is just to be interacting with as many smart founders as possible. You definitely came onto our radar fairly early on, and we're like, okay, like we need Caleb around, and so we'll walk up pretty soon, and you'll see like his desk is right behind mine. We talk all the time. I'd consider him a friend. I don't know if he considers me a friend the other way.
I used to, the thing is, talk about KJ, I used to watch KJ's channel when I was in high school. And like when I was applying to MIT and stuff, like I was like, day in the life of MIT, whatever. And I watched all of your videos. It's such a cool thing to have. Like, I think it's hard to find people with similar experiences to kind of motivate yourself off of. And your channel definitely did that for me. So
yeah, and moving forward, like, first of all, you're welcome, and this is like why I do all of this. This is why I take the time to make videos like this one. And hopefully, like, if you want to see more videos like this, just let me know in the comment section, because Caleb's always down.
Yeah, I love doing this stuff.
In more videos in the future.
That's right.
And I'll definitely link to all his stuff also, because he's documenting this server building journey also. But yeah, we'll head back upstairs.
All right.
And we'll go to your desk and you show me some other stuff. Yeah, so for context, this is my desk, like you notice, and Caleb's literally right there. And so he wanted to show me some stuff on his computer.
So I wanted to show everyone like a sample program. So this is actually how Howard works. So this is one chip. There's 8 of these on Howard. And the way it works is there's like a mesh of these chips. So you can see there's a grid. These E chips are called Ethernet cores. These are the ones that like manage the kind of off-chip communication. These D cores are called memory cores. They are the ones that manage like storage of information. And then these green ones here are the actual like ones doing the math and worker cores. And some of them are actually disabled for manufacturing reasons. You essentially just and power distribution reasons also. So we have these ones working right now. And there's also one core here for doing communication through PCIe, which is like how it actually slots into the CPU. So yeah, this is just like a sample. Like I think this is full network on chip utilization. Oh, and that's the other cool thing about Howard, where it's like Howard has something called a programmable network on chip, which means all of these cores talk to each other in this big mesh. And there's actually two of them, one that goes this direction, and then one that goes this direction. So using those two different networks, you can kind of communicate between all chips. And yeah, and the other cool thing actually is, so each of these chips here, we can actually pause this simulation and see like all the different requests that are happening. Each of these chips actually like 5 mini RISC-V cores on it. So 2 of them are used for communication with both the network on chip up and down. It's called a NOC. And one of them is used for doing the math, and the other 2 are using for formatting and serializing data. And this is actually like a really this is a really big actually representation of the kind of distribution of compute around AI, right? Where it's like you have information that's moving through, you have to process that information and get it in the right format, do the actual matrix multiplication, math, activations, functions, and then communicate around with a whole bunch of other stuff. So there's a lot of different algorithms you can use for doing this kind of distributed mesh programming, and that's what I'm kind of getting into now. But yeah.
What challenges have you experienced with Howard?
Yeah, well, I mean, there's general problems around like I did not know how to like build a server, like what the components of a server was. So I had to learn how to do that.
And how did you? Like what path did you take?
A lot of just like trial and error research, learning about like seeing people set up different servers, learning and like reading the manuals, actually like with help of AI, obviously. And then also, I think once everything got set up, just like debugging the entire system, getting familiar with their code base. The code base for this stuff is like massive. There's just like so many different, like if you can see this, it's just like, there's so many different different drop downs of drop downs of drop downs of drop downs. There's just tests, and there's like the actual library, and then you can keep going down into like more stuff, and then there's more stuff, you know what I'm saying?
Yeah.
So it's like getting familiar, because there's a structure to all of these things, right? It might look very complicated at first, but then you realize like, hey, like things are grouped there for a reason. I know where general things are. I can kind of find things eventually. So kind of like marinating in it and staying there and being comfortable, I think was pretty tough. And then I think the other thing is just like converting my ideas that would have worked very easily with existing tool chains onto this. Because you have to really think from the ground up. And I think it's really important. We were talking about this earlier, right? So I think it's really important to kind of work through problems from the ground up, because then you have a really good basis for like what you can do, what you can't do, why. So yeah, I think that. And then also just like sticking through, because like it's not always easy. It doesn't feel good all the time to fail. But you know, you learn from it, and then eventually you get used to it.
And so if someone was coming in and they maybe click on this video because they want, you know, exposure to how to work on these servers, these AI systems from the ground up, like, would you recommend they just take the same path that you took?
I think I could have. Okay, so there's this trade-off between like excitement and fun and like ease, and I think it is important to balance that, because things can be easy, but you don't feel satisfied from doing them, which won't motivate you to do more things. So I definitely could have taken a somewhat easier route, but I also thought it was like cooler to have my own server that I got to set up, right? So again, there's that trade-off, right? If you have a real reason to use it, and like you want to do that very quickly, it might make sense to just go into the cloud directly and then work your way up. But yeah, I would say also the community is also super helpful. So like I'm very like connected. Like I got to go to their developer day and meet like a bunch of like the core engineers behind a lot of these chips. I was invited, partially because of like my posting on this stuff. So it's lean into your community for whatever the system you're working within. And like if you're doing with AI chips, there's things like GPU mode and things like that like work with just chips in general. Maybe not TenstorRent chips, but you know, shout out TenstorRent, you know, Jim Keller, the GOAT, and shout out Felix. But yeah, I would say find people who do what you do, because at least then you have like when you know nothing, you can always just double check with them. And there's not always a lot of resources to learn about these things very easily, so they can always be the only source. So I say, don't be afraid to rely on the community, and then also just don't be afraid to struggle. Like, it's okay to struggle. Like, it's okay to feel dumb, because if you realize that, like, you'll probably like solve the problem in like a week or two, but like once you've solved it, you realize like, wow, I have solved this now for the rest of my like time using this, and like now I can build a bunch of other stuff on top of that. So yeah.
Okay, so I just stepped downstairs again so that I can formally outro this video. If you want to see more content like this, let me know in the comments section. Also, let me know in the comments what resonated. Was there anything too technical? Did you want him to dive even more technical into his project? Just let me know. And as always, stay positive, stay inspired, and I'll see you in the next one.